Hey, physicists, what's the crack? So today we're going to tackle a little bit of electricity. So this question looks quite similar to the ones you would have seen in GCSEs, but it's different because in A level, you have to be able to calculate the resistance when things are in parallel, okay? So it says we want to find the potential difference across the power supply. So imagine we've got a voltmeter here across my power supply, and I want to figure out its internal resistance. So internal resistance, remember, is when we say the cells aren't actually perfect. If the cells were perfect, they would give me out 1.6 joules of energy for every electron. But because there is some internal resistance in the cell itself, the electrons lose some energy. There's some lost PD within the cell itself before it actually leaves the cell. So we're trying to figure out what is that internal resistance and then what is the energy they actually come out with. Okay, each electron, how much energy comes out with. That's what the PD is. Okay, so the equation on my data sheet to calculate this is V equals EMF minus I times R. So the potential difference across the cell equals the EMF, what the cell can actually give me if it was perfect, take away whatever current is flowing through it, times by the internal resistance in my circuit. So already I can just pop in 1.6 minus 0.238 times R must be V. Okay? So the first thing then I can calculate is V, because V is the potential difference across the circuit. And we know from GCSEs, V equals IR. So I can calculate what V is if I know what the total current is and the total resistance is of my external circuit. So the total current, again, is 0.238 multiplied by whatever the total resistance is of the external circuit, kind of just like GCSEs. So again, these four are all in parallel with each other. So the resistance equation is 1 over RT, 1 over the total resistance, is equal to 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4, because we have 4 circuits. Pardon me, 4 resistors. So I know what R is each time is 22. So all I have to do in my calculator is 1 over 22 plus 1 over 22 plus 1 over 22 plus 1 over 22. So hopefully you can all see that 1 over RT will then be equal to 4 over 22. But remember, that's 1 over RT. So to find what RT is, you have to flip the fraction. So it's actually 22 divided by 4, which gives me a final answer of 5.5. So now that I know the resistance of the external circuit is 5.5, I can just plug that number in there to find out what V is. So I do 0.238 times 5.5, I get a final answer of 1.309 volts. So that's what my voltmeter says. So the first part's done. So now I can write that number in there because I know what that voltmeter says. It says 1.309. So all I need to do now to find what that is I can write 0.238 times the internal resistance, because you take it over to this side, it becomes positive, must equal 1.6 take away 1.309. So when we solve then for little r, which is our internal resistance in our cell, you're going to get a final answer of 1.26 ohms. And that's grand.